Hello, dear participants. I would like to welcome you to another Focus Week webinar revolving around user-centric EA portfolios. The title of today's session, Use Data Profitably, Unearth the Treasure of the 21st Century with Data Portfolio Management. This title gives us already an idea of just how important data portfolio management can be for a company. It's not just simply about collecting a lot of data. No, today we will discuss how data portfolio can be discovered, distributed, but also the importance of the quality, integrity, and availability from data that is critical to a company and what can be expected. My colleague, Michael Kamberov, is going to explain how you can efficiently set up your portfolio, as well as how you can use it for your own transformation initiative. But first, let me introduce myself. My name is Mahmoud Al-Khalid. I'll be your host for today's webinar. My colleague, Michael Kamberov, our EA expert, will now be guiding you through the rest of the presentation. Michael, I'll let you take over.
Thank you for the introduction, Mahmoud, and thank you everyone for signing up to this Enterprise Architecture Focus Week session. As already mentioned, our session will focus on how to leverage data efficiently and effectively with the main principles of data portfolio management. We'll first begin with a more conceptual overview of enterprise architecture management and the role that data portfolio management plays in our digital transformation initiatives. Afterwards, we will dive into our best practice approach to data portfolio management, followed by a live demonstration in our enterprise architecture tool, AdoIT. To kick things off, let's take a look at our introduction to enterprise architecture management. So typically, a company consists of several different levels, and this is again more from a conceptual perspective at first. The levels then, from a more enterprise architecture point of view, can be broken down into the respective layers of the architecture which we see here. For example, transformation, data, application architecture, and so on. Different companies choose to address and manage these levels differently. Some organizations prioritize the documentation and management of each layer. Others exclusively focus on only a subset of the layers. And some organizations, typically large enterprises, focus on all of these layers and more. Nonetheless, the levels that we see here are typically present in most enterprise architecture practices and in most organizations. The levels themselves can be represented in different ways, and organizations might choose to document information to various levels of detail within each layer. Transformation projects can then extend over several layers of the organization and several layers of the architecture. So naturally, the transformation projects can also focus on a single layer, for example, a project within the application layer of the architecture. But because the different layers of the architecture are typically interconnected and because they rely on each other, transformational initiatives usually cover a lot more ground than what we might see within an isolated layer of your enterprise architecture. From the transformation view, we can also derive the portfolio view. The portfolio view essentially presents us with the understanding of the various architecture portfolios, which will play a role in our digital transformation. We can identify which portfolios are most crucial and which individual assets are critical to the success of our transformation project. The portfolio view and the transformation view are also conceptually interdependent. While the transformation view is more logical, the portfolio view shows us the real data within the enterprise. The transformation view is refined based on our understanding of the portfolio view, and the portfolio view is eventually changed and improved based on the outcomes of the transformation projects. What we're going to take a look at next is the data portfolio management and the specific roles that it plays in our enterprise architecture and in our digital transformation initiatives. The first slide here serves as a high-level insight into the core pillars of data portfolio management. And this is also the pillars that we focus on as we build up this initiative and focus data portfolio management within the projects that we do with our clients. So some of the first things that we focus on, for example, is the identification of the correct stakeholders that need to be involved in the initiative and what their relevant roles are in the business. This is, of course, a very critical aspect because, like with any project, you need to make sure that you're relying on the correct people and on the people that are involved within the specific management domain that you are essentially building up. In this case, of course, data portfolio management. Once the stakeholders are defined, we typically start collecting and identifying the critical questions that they're trying to answer within the scope of the project that we're doing here. This can help us also derive and have a more focused view of the methodical approach to tackling the questions and the challenges that the stakeholders are trying to essentially answer and eliminate. And subsequently, after the methodical approach is defined, we can start, of course, documenting and enriching the architecture, eventually building up different architectural descriptions in the forms of different viewpoints of the enterprise. And once this documentation is completed, we are able to start performing analysis, evaluations, and start having findings, which essentially will support the transformational initiative within the enterprise. To dive deeper into this concept, let's take a look at our methodical approach to data portfolio management. The first step for us is to collect the data. In this step, the data elements are identified and described in detail. The description of these data elements contributes to the introduction of a common vocabulary and thus a common understanding throughout the entire organization. So this is a first step towards ensuring that the data in the data portfolio can be efficiently reused across the entire enterprise. The first step is to determine the appropriate level for capturing data and to define the set of properties with which the data needs to be described. The subsequent activity begins with the actual collection of the data itself. So very often a good starting point is the business process documentation, for example, or the capability maps from which the relevant data elements can actually be derived and sourced. To give an example from, let's say, the process world, the input and output data can be determined, let's say, from the steps of a business process or even from the documents used within a business process. Finally, what we do next is that for each identified data element, we understand that it's necessary to designate a person in the organization who will be responsible for collecting and maintaining the properties of these data elements. Next step for us is to evaluate the data. So once the data has been collected, it can be analyzed. In practice, it is recommended to focus on the data elements that play an essential role in either the current or the future transformation projects. You can also focus on the data elements that significantly influence the business itself, or the data elements that play an important role from the point of view of data protection, for example. The data can be evaluated from three different points of view, typically the business, technical, and regulatory perspective. And the first one that we're going to focus on a bit more now is the business perspective. So the focus here is on the quality aspects of the company's data, right? So the quality of the data must be therefore checked on a regular basis. Such an evaluation can be based on the completeness of the data. For example, are all the relevant properties of the data captured? It can also be based on the uniqueness of the data. Are, for example, duplicates of the data available? Or it can also be based on the correctness, the relevance of the data, and so on. But essentially, what we're focusing on from the business perspective is the quality of the data. From a technical perspective, we must determine how IT systems and other architecture elements, such as your business processes, are going to access the data. So as a rule of thumb, it can be stated here that exactly one application per data element must be the so-called master of the data. This means that all essential properties of each data element can be maintained by the master application alone, right? So other applications can then access the data by interfaces, and this way the integrity of the data can be ensured. So once again, you have a single master application, which is essentially managing the data. Other applications can still access the data, but having a single master application is how we can ensure the integrity is maintained. You may also be familiar here with the golden source principle, which is exactly based on having typically a single source application. In practice, we very often find violations of this principle. It's quite common. For example, if you have a situation where you're introducing a new IT system within the enterprise, let's say it's a new system that is going to impact the customer data. And introducing a new system might result in data being maintained in two systems. So to stick with our example of the customer data, the data might be maintained by the new system which we're introducing, and in some areas of the company, the old system that was used until now. And in such a use case, information like the customer addresses, for instance, can then suddenly appear in different formats in each system, which means that the quality of the data can no longer be guaranteed. Last but not least, within this particular stage of the methodical approach, we have the evaluation of the data from a regulatory perspective. And here, what we essentially focus on is the fact that data protection plays an essential role. For example, GDPR, where personal data is subject to particularly strict legal restrictions. Next, we have the identification of potential for improvement. The first step for us here is to analyze the data portfolio. So on the basis of the data collection and evaluation that we've done in step 1 and 2, a certain need for action can then arise. We must be able to identify potential for improvement based on our analysis, which eventually leads us to the fourth and last point of our methodical approach, which is the derivation of requirements or measures. Certain measures for the enterprise architecture can be derived from the identified improvement potential, which in turn leads us to the concrete definition of projects and transformation plans, which are going to have a larger impact on the overall enterprise architecture initiative. This concludes the more conceptual introduction into our topic for this session. We will now proceed with a live demonstration in our enterprise architecture tool at OIT. In OIT, we're going to run through a more practical example of our methodical approach to data portfolio management. We will begin by creating a new data element and gathering some of the core properties of that data. These properties will then be used for analysis of our data, based on which we can derive requirements for improvement of the enterprise architecture. What we see here is the start page of our OIT instance, from where we can actually kick off the data collection. And of course, from here, we can very easily continue our work depending on where we last left it, with some of our helping dashboards that we see in the start page. But what's most important now in the context of creating a new data element is to navigate to our new dashboards. When I click on new, I'm redirected to a separate page, a separate dashboard in OIT, which is now tailored towards content creation. From this perspective, we see the full scope of the standard OIT Meta model and what it supports in respect to documentation. We base our Meta model on Archimate as the worldwide standard for enterprise architecture documentation and modeling. And the Meta model that we see here, as well as OIT in general, is compliant with the Archimate 3.1 specification. Of course, this is a more comprehensive view. We see all the different object classes across all the different layers of the architecture. But from this perspective, we might want to focus on a specific layer within which we want to document, in this case, our data portfolio. For that, we can activate one of our filters. And for example, we have the business filter based on the business layer of the Meta model. Once a filter is applied, then we see a more condensed view of the dashboard. And now we have a selection of the objects that belong to that particular layer. What we're going to be working with today is the so-called business object. In Archimate, and typically also in enterprise architecture in general, the business object serves as the logical representation of data. So we're going to take our business object here, and we're going to use it to create our new customer data. So as I click on business object, the system automatically creates that new element for me, and it gives it an automatically assigned name, as we see here. But now we actually want to start documenting and enriching the object that we've just created. To do so, we are going to leverage the properties of the object, as we call them in OIT, or another word that we use here interchangeably is the notebook of the object. We also call it the notebook because it has different chapters, and every chapter allows us to document different pieces of information, as we're going to see in the next few minutes. So going back to our general section here, we have our business object, and let's name it, for example, customer, as a representation of the customer data. I'm going to trigger a save right now, just to make sure that we, of course, have the object saved. And from here, we can now continue the documentation. So we've already given the name of the object. The example that we're running through today is based on customer data, something that we're all familiar with. And next, for example, we can add a description. So let's say here, we're going to say this is the customer master data of persons or companies who have completed a transaction of our products and services. Now we have added a description, and typically this is a very, it's the basic level of documentation when it comes to creating a new element. You want to give it a name, you want to give it a description so that whoever consumes this information has a better understanding of what they're actually looking at. Next, we're going to dive into some of the other properties that we have for this element. First and foremost, the organization chapter. In the organization chapter, we have the possibility of defining a RACI assignment based on different stakeholders who might be responsible for the assets at hand. And here, for example, the most important one is the responsible business actor, where we want to assign a specific stakeholder who is essentially assigned to this particular data asset. And in my case, I will simply assign myself to that. So one way to do that is to simply click on the plus button here, and I can quickly assign, for example, my user, the one with which I logged in. His name is Ark. He is the main architect for our fictional scenario that we're working with here today. Assigning a specific user to any element means that they will be able to see that element within their dashboards, within their collection of assets that they're responsible for. And in different use cases and examples, they might get notified when certain changes occur with the assets that they're responsible for. So, ownership is critical in enterprise architecture in general, but also in the context of IT, it's helpful to always assign a dedicated owner or responsible person for every strategic asset. Next, what we have here is the relationships section. So relationships are quite critical in enterprise architecture because they allow us to build interdependencies between objects and between different layers of the organizational architecture. So with Archimate, we have a very rich set of relationships that we can work with, and these are aggregated based on the 4 definitions here: structural, dependency, dynamic, and other relations. Once again, this is all based on Archimate, but Archimate in general offers a very comprehensive set of relationships that you can use even if you don't want to strictly follow the notation. To facilitate the assignment of relationships and the building of relationships in IT, we have basically created a drag and drop functionality, which works together with a suggestive mechanism that allows you to choose the best relation for what you're trying to build. Let me give you an example of that. We're going to now think about, okay, which processes basically access and work with the data that we have here at hand. So I can go into my repository, which is the library of all my content. And from here, I can now search, for example, for one of our processes, let's say financing. That's one of our core processes in our scenario here. What I meant earlier with the drag and drop is that I can take any asset from within the repository and I can drag it on top of the properties, in this case of our data. And as you can see, we now have a selection of relationships that we can work with. So as I mentioned previously, this is the suggestive functionality of drag and drop, where you're basically able to select the correct relation for what you're actually working with. And in our case, with the process, we want to use the accessed by relationship. This is typically the one that we observe between data elements and between processes, where the process is somehow leveraging the data, which in the context of Archimate, we document using this accessed by relationship. We can add another process just to stick with our example. So we have another one called advice customer. So we can do the same thing, drag and drop and build that relationship. Another very typical example with data is to consider, for example, which systems, which applications are actually leveraging and working with this particular data. We're going to do the same thing again. So this time I'm also going to now search for our partner applications. We have quite a few of those. So we're going to take our business partner and our partner system, 2 strategic applications in our architecture, which are essentially, again, working with this data. And here we're once again going to use the accessed by relationship. So slowly but surely, we're basically building up our documentation here. And as we discussed previously with our slides, we're talking about an approach where once we start capturing data, we want to focus on the key properties and the key elements of the documentation which help us understand our data better and which can subsequently serve as an opportunity for us to evaluate the data. What we can also focus on here from a more strategic perspective is our capabilities. Right? So we have a high-level capability called, for example, partner management. And what we can say is that our particular customer data here is helping realize this capability. This is a very common relationship that you would work with in Archimate, especially when it comes to capabilities. You would have subsets and assets of the architecture, which are, again, realizing or essentially supporting the, the provision and the overall run of given strategic capability in the organization. So in this case, our partner management. And last but not least, to wrap up this initial documentation of our customer data, we are going to take a look at a tagging or a labeling mechanism that we use in IT with the so-called grouping elements in Archimate. Grouping elements are quite flexible. They can be used to basically aggregate different assets within a specific grouping. But typically, what we work with in that context is that when we take a grouping, we use it as a method to label or to basically tag different assets. So here I have a grouping which is more relevant to the regulatory examples that we discussed with the slides. As mentioned, one of the key pillars of evaluating and assessing the data is in the context of regulatory requirements. And here we have a grouping, GDPR relevant, as you see here on the left, which indicates that, again, any data element that is relevant for the GDPR regulation can be tagged using that label. So I can simply take our grouping, and as we've seen previously, I can simply drag and drop it on top, and I can then, for example, choose the aggregated relationship. That's the correct one to use in this context. We're basically saying that our customer data, as we see it here, is aggregated underneath a grouping, therefore serving as the example of, okay, this is a tag, this is a label, making sure that we now know that the customer is a GDPR relevant piece of data. So this is more of an overview of the relationships approach that we take to essentially enriching the documentation. And we're going to take another quick example here with our data classification. In the context of classification, we have the so-called security requirements, which allow us to basically score our data against the standard CIA requirements of confidentiality, integrity, and availability. From a security perspective, this is a very common, basic level assessment of data, and is one that our clients use to, again, evaluate their data, and which we also leverage in our overall data portfolio management approach that we're seeing here today. So here, for example, from this perspective, I can make a scoring. So I can classify, for example, the confidentiality as very high. Also, let's say the integrity is going to be very high, and our availability is going to be high. So it's a very quick mechanism, but it's quite handy when it comes to security, and it serves, as I mentioned before, as a quick baseline for security-based assessments. We can, of course, continue the documentation and the enrichment of the data using different properties. For example, we can discuss the life cycle, where we can define an overall, let's say, time period within which the given data will be valid within the architecture. We can also play around with concepts like specialization. This is, for example, transactional data, inventory data, master data, and so on. But as far as our example today is concerned, this I think is a good level in which we can dive into for the basic documentation of the data. Given that we've now completed this, if we want to take a quick look at how the documentation now looks like, we can switch to our read view, for example. The read view simply filters out anything that you haven't documented, and it simply focuses on the pieces of information that have been documented. And most importantly, here we can go to the organization section to take a look at, for example, the assignment of the responsible stakeholder. In the relationships, we have the key relationships that we built, the fact that the customer is realizing our partner management capability. It's aggregated under the GDPR grouping, as we mentioned before, basically tagging it with a label. And it's also accessed by a number of assets, processes, application components, and interface. And from a classification perspective, we also have the high-level security assessment that we see here. Now, from the perspective of documentation, we've already seen a few examples of that, but another key aspect of IT is how do we actually then consume this information, right? So how do we represent it? How do we make sure that our stakeholders and our users are leveraging this information? And one aspect, of course, is what we see here today, the possibility, of course, to open the properties and just consume information from this perspective. But arguably the best way to consume information in IT is not in this format, but with what we call the insights. The insights are automatically generated dashboards, which you can basically run for multiple elements. And you're able to then take a given asset, like our customer data here, and have a ready-made dashboard which serves as a collection of all the key information for that given asset. So here we see our customer data. We see the description mentioned above. If there's any labels or any tags, they're going to be visible here as well. So here we can see, okay, our customer data is GDPR relevant. And now we can scroll through the different widgets and basically start consuming and understanding the data that we have documented here. From the organization, we see the responsible owner, the responsible business actor, our user who we assigned earlier. Next, we have, very importantly, the relationships network. This essentially has a high-level overview of all the key relationships that your asset has. And for example, here we focus on the different object types. So for example, we see customer. It's related to the business process object type. And when we click on it, we see which specific business process objects this data is actually linked to. Next, we can see, for example, the application components. As we click on it, the network expands. And using this approach, we can essentially gradually understand and map out and start consuming all the key relations for any given asset, as we see here. So again, the main concept here is consumption of the information rather than going into the old-fashioned properties-based approach. The insights allows for a more focused and yet comprehensive overview of the most important information that we have for our data. Next, we have the relationship details. So this is the section that we see here below. So once again, we can focus on the different relationship types. And now this is, of course, more graphical, the network, but the details below helps us understand a bit more about the underlying assets. So first of all, we can see the specific relationships that are used. So here we can see the access relation is being used for our applications and for processes. For each object, we can see also the key stakeholders involved, and also these objects themselves are labeled under different groupings and tagged. Next, we have for example, the grouping relationship with aggregation to the GDPR label, also the capability relationship and the one-to-our interface. The next section for us is the so-called data flow. The data flow is similar to the relationships network, but this is now more, let's say, all-encompassing because it doesn't only consider your customer data that you've created, but it also considers other data elements and other assets across the architecture that basically interplay in the context of data flow. The main logic of this diagram here is the following. We have a specific data element, in this case, our customer data, and the customer data is associated with all these different assets. And the associations that we observe are based on the core relationships, for example, with partner system, as we defined here earlier, and also with business partner. And all the other assets that we see in the surroundings are basically assets that these two applications, business partner and partner system, also communicate with and therefore exchange and might share this customer data with. And because of this overall network and the consideration of our application architecture, the data flow can also visualize all the other strategic data elements that these same application components are actually exchanging or sharing data with. So this allows us to consider not only our core asset, being the customer data, it considers also, again, systems that might consume the data and what other data elements these systems themselves are also interacting with. The data flow allows you to focus on a given data element, as we saw here before, but it also allows you to focus on a given application component. So if I'm interested in the partner system, I can click on that, and I can see, for example, our core data element, let's bring it back here, but also all the other elements that this partner system is actually somehow connecting to. Next, we see the data usage. Data usage refers back to also something that we assigned earlier, basically which application components are directly accessing and using the data. This also allows us to document from the perspective, let's say, of the golden source principle, whether or not given applications are the master of any given data elements and what type of access they have. But this is an example that we're going to dive into a bit later as we go into the assessment and the evaluation phase of the documentation. Next, we see classification, where we can have the scoring based on the criteria that we saw earlier, confidentiality, integrity, and availability. And last but not least, we have the application section. And the application section goes back to the core relationship between the data and the application layer. And what it basically showcases to us is the fact that we have two application components which are accessing and working with this data. And we can see the relevant assessment and scoring of these application components. Typically for applications, we focus on criteria such as the fitness on criteria like business, IT, cost, security, business continuity. So this is displayed graphically, and it allows us to gain a quick understanding of the overall assessment or the scoring, as I mentioned earlier, of the applications which are accessing the data that we see here. This can also help us think if, for example, the application architecture can impose specific risk to the data based on the specific application components which are actually working with that data. Good. So, as mentioned, the insights for us is an aggregation of all the key relationships, all the key data, basically all the most important information for any given asset that you're actually working with. Going back up and referring back to the golden source principle example that we discussed earlier, we can now take a look at how that can actually be documented. So I'm going to go back to the properties of our customer data. And in the relationship section, we have, as you remember, the business partner and the partner system, which are the two application components which are accessing our customer data. And from here, what we can actually document now is the mastership of this particular data. What I can go into now is basically the properties of the relationship between any given application and between our data. And on the level of this relationship, we can define the so-called access type, and we can define the mastership. What we discussed earlier during the slides was the relevance and the importance of the golden source principle, where we say that there should be one application which is the master of a given data type. So let's assume that for this case, our business partner application is the master of the customer data, in which case the access that it would have is read and write. So this application can both read and write the customer data, and it's assigned as the master. Going through this exercise now allows us to define that in this case, what we see is the mastership of our customer data from the perspective of a specific application, which naturally has the full access to the data. We can do the same thing for the partner system, which is our other application that is accessing the customer data. And here, obviously, the partner system should not be the master of the data because we already have a master. But from an access type perspective, typically when an application is not a master of the data, it should only be able to read the data. But now to purposefully create a conflict in the golden source principle, we're going to say, okay, the partner system can also write the data. This is typically something that we don't want, because if two or more applications can write a given data, then it means that they can essentially change or even delete the data, which should be typically in the purview of the master application alone. We're going to observe an analysis of this mastership concept and the golden source principle a bit later, but for now, I just want to quickly showcase how we would typically document this in AutoIT. Good. So we went through the example of the documentation of the data, the capturing of all the core properties, and next we can dive into some of the principles of the assessment. So what we can take a look at next is basically a high-level evaluation of our data, for which we can take a look at our data evaluation model, which we've prepared for today. What we're looking at here with our data evaluation model is a high-level representation of some more strategic goals and principles, as well as specific requirements against which we basically want to assess and evaluate the data. What we can consider here are the main principles that we discussed earlier in our data portfolio management approach. And the first level at which we want to evaluate the data is from a business perspective, which is what we see here on the left-hand side. So a high-level goal that we're trying to achieve is the high quality of the data. And the specific requirements that we're considering is the completeness, uniqueness, and the lack of redundancy within each data element. One of the things that we focus on here, as mentioned, is the completeness of the data. Here, we must check the data and assess if all relevant properties and characteristics of the data are actually captured. For example, what we did a few minutes ago with the assignment of the responsible persons, the key relationships, the CIA assessments, etc. Next, we have uniqueness. We want to make sure that this is the single instance of this data type documented in our portfolio. And essentially here, what we're trying to focus on is the fact that we must have no duplications of the data. And lastly, we have redundancy. Looking at our portfolio as a whole and assessing if a defined data element is even required is basically what we're trying to do here. So again, we're performing this assessment based on the overall amount of available data, and we're trying to understand essentially if there's any redundancy. So this is important, as sometimes the lines can get blurry as we document a lot of data in our portfolio and some properties can overlap across multiple data elements. And that's the main principle here of redundancy as a requirement against which we want to assess our data. The second pillar of the evaluation approach as discussed earlier is the technical perspective, where we have the high-level architecture principle of the single source of truth and the specific requirements of having a defined master application. So this is exactly what we saw earlier, and also we discussed with the slides. We want to focus on having a master application which essentially is going to be the single asset that is mastering a specific data type, going back to, of course, our golden source principle. Here we want to have a master application and a defined read and write strategy. And we must make sure that there's no violations of the golden source principle. We'll take a deeper look at this in a few moments with our read and write matrix. The last perspective of the evaluation is the regulatory one. So here we have a high-level goal and two specific requirements that are in the context of GDPR. The first one is set up a backup system for personal data. Again, this is in the context of GDPR, as well as hot standby backup system for data with high availability. This is an example with a different requirement that applies to only a subset of our data portfolio. So as you can see here, the requirement specifically mentions data with high availability. So here we want to observe only data elements which in the context of their CIA assessment have a high availability scoring. To properly perform evaluations in such cases, we must run a detailed assessments of our data portfolio, which we're also going to see an example of in a few minutes. Good. So one of the things that we discussed specifically here was the golden source principle with our technical evaluation, the single source of truth principle, and the defined master application requirement. To observe this, we're actually going to leverage our read and write matrix in AutoIT. So let's take a quick look at that. What we see here with our read and write matrix is essentially an aggregation of all of our data elements across the data portfolio, as well as all the applications that they have a relationship in the context of mastership and the read and write strategy. That is also displayed graphically here. And in this context, we have a pre-configured matrix with our previous version of the data portfolio. But now, of course, we have newly created documentation, newly created data, which we want to make sure is included within our report. And to do so, to basically include, more importantly, our customer data, we can simply click on Complete Matrix. This functionality basically checks the documentation and makes sure that any missing part of the portfolio is included in the report. And here we go. It's now updated. We have added a few additional elements, most importantly, our customer data that we see here. So we can see in the matrix, as we zoom in, we have the customer data, and from a perspective of the business partner, we see that we have the mastership, which is outlined by the green border of the cell that we see here. And in this case, we also have the read and write access right. Because the business partner is the master of this data, we actually have the, of course, support and the validity of the fact that both read and write access are available between this system and between this data element. As we scroll further into our matrix, we can see if there's any conflicts, which in our case, there is one, based on the example that we built earlier. And the conflicts are typically occurring whenever you have, as we said before, an application that is not the master of a specific type of data. If that application has the ability to write this type of data, then we have a conflict. This might cause, let's say, duplication of data. It might cause data loss. It might also cause some redundancies in the documentation. Typically, what we want to see in such cases is that, again, applications that are not the masters of specific data can read the data, as we see here with these two examples. Two non-mastering applications that can read the data, there's no violation, but we want to make sure that whenever there is the possibility of writing data from a non-master application, that is highlighted, and that's what our matrix basically does here. It considers the entire data portfolio, and it highlights to us all the cases where there's a conflict and a potential violation of the golden source principle. Anytime a non-mastering application can write data, that is a violation of the golden source principle. And the, again, exact purpose of this particular report and assessment is to highlight those cases so we can focus on mitigating them and avoiding such violations of the principle and any potential danger to the data. The last thing that we'll take a look at today is our support for the regulatory assessments with the help of our add-on compliance module. We use our compliance module today to observe the assessment of our data against the requirement of having a hot standby backup system for data with high availability. So this is the example that we discussed earlier with our data evaluation here. So this is exactly the example that we saw, and that's the one that we're going to also entertain using our assessment module. So let's take a quick look at that. To access our assessment module, we can simply go to our reporting dashboards, and from here, go from the reports filter onto the dashboards filter. From here, we would have access to all the available dashboards in the system, and most importantly, in the context of the assessment, our so-called compliance module. When we open the compliance module or the compliance dashboard, to be exact, we're directed to the dedicated dashboard of our assessment module. And the assessment module, the main principle behind it is that it considers specific requirements that are assigned to aspects of the architecture, like the requirements we saw being assigned to the data. And it is able to automatically create and run assessments against each requirement that is assigned to, for example, our data. Right. So, for example, if we have a given data element like our customer data, the assessment module basically considers all requirements assigned to that data, and it creates individual assessment objects that help us basically assess the compliance of data against each individual requirement that is assigned to the data itself. So from this perspective, the dashboard that we see here shows us an aggregation of all of our assessments documented in the architecture. And as you can see, these assessments actually occur multiple times. So we have the same assessment of the same requirement occurring multiple times. And the reason why this is the case is because, as I mentioned a few moments ago, we have a creation of individual assessments for basically each requirement against each data or each element of the architecture that particular requirement is actually run against. So for here, if we see, for example, here the redundancy assessment, it basically is created for each instance where the redundancy requirement is assigned to a data element. So we see it assigned here to our customer data, but also to other data elements such as our contract data, our account data, our loan data, and everywhere that requirement is assigned to data, we have a dedicated assessment for that, because of course, we want to assess the compliance of each data against each requirement individually. That is essentially the fundamental principle of how the assessment module works, and also what we see specifically here with our examples. So we have customer data, and we're going to notice that the customer data occurs a few times. So we have also here the completeness requirement in the relevant assessment, the master application. We also have here, for example, the backup system, one of the GDPR requirements, and so on and so forth, as well as, of course, the setup of the hot standby backup system. So each requirement is present within the system, within the environment, and therefore we have individual assessment against each one. We see also in this particular widget of a dashboard, there's a status of the assessment. So each assessment is active, meaning that we're still working on that assessment. We see, for example, very important, the responsible stakeholder. Here we have once again the user that we used earlier, and we also have the possibility to actually score the degree of fulfillment. So essentially what the module does for us is that it creates the assessments against each requirement and the objects that it applies to. In our case, of course, our data portfolio, but also what it gives us the opportunity to do is to basically assess the degree of fulfillment. And the degree of fulfillment serves as a measure of us defining how the requirement or how well or how completely the actual requirement is fulfilled by the data that is being assessed. So because we have these newly created assessments for our customer data, that of course is not defined yet. But as you can see from most of the other data elements, we have that information already defined. What we also see here is the value at risk. So we can also basically assess the risk of each assessment, meaning how essentially based on key attributes such as the likelihood and the impact of the risk, we can then derive an overall risk value of the assessment that we're actually pursuing. And we also have the element of data actuality, which allows us to basically confirm how up to date and how accurate each assessment is actually scored. All this is also described in more detail in the properties of each assessment. And in addition to what we see here at the top widget, we see the additional widgets below, which allow us to filter and assess this information in a bit more structured approach. So the pie chart that we see on the left-hand side basically shows us a filtering mechanism for all of our assessments based on the degree of fulfillment that we see here. So if we want to focus on all these specific assessments that are not basically defined yet, from a fulfillment perspective, we can click on that piece of the pie, in this case, our gray piece. And now we have an aggregation of our customer data, as we said before, because that is the, again, the data that we just created and that we're still yet to assess. What we also see here on the left is a widget that shows us the value at risk. So it's a mechanism that allows us to quickly identify which assessments basically contain the highest value at risk, based on which, again, we can also focus on those and individually then start assessing and understanding which specific data elements we need to focus on first with respect to how they comply with the given requirements and how we can all use this mechanism here and what the systems provide us with as input for reducing or completely eliminating the risk. So this is sort of a quick crash course and a high-level example of the assessment module and the dedicated compliance dashboard that it offers. As mentioned, essentially, we're considering the data portfolio, all the assets within that portfolio, the requirements that these assets basically have to comply against, and the module which creates assessment elements that helps us assess the compliance against the requirements for each element within our data portfolio. So today we went through all these examples with our customer data. We went through, of course, the core principles of our data portfolio management approach from the initial capturing of the data all the way through to the evaluation and the gathering of specific input that would help us improve the data portfolio, but also the overall enterprise architecture. That concludes the live demo part of our session today. And from my side, I just want to say thank you for joining this Focus Week session on data portfolio management. As mentioned, we began our session with sort of a high-level overview of our approach, data portfolio management, after which we saw a more practical example built up in AutoIT with our customer data. With our example, we were able to quickly run through the main principles of our approach, and we also saw an example of some of the advanced assessment capabilities in AutoIT with our add-on assessment module. I hope you enjoyed today's session and that you found it valuable. In case you have any feedback or questions, please do not hesitate to reach out to us. Make sure you also check our upcoming Focus Week sessions, which Mahmoud will tell you a bit more about. Once again, thank you, and over to you, Mahmoud.
Well, thank you, Michael, for guiding us through today's Focus Week's webinar and giving us a well-rounded base from which to continue exploring. Now, dear participants, if we have made you curious regarding EA initiatives and just happens that you're looking for the right tool to get going, well, then you are more than welcome to follow the links below and get our free AutoIT version, the AutoIT Community Edition. AutoIT users can always reach out to our experts and consultants regarding any questions on their EA portfolios. You can also reach out to us directly over our website or contact your key account manager. During the course of this Focus Week, we'll be looking into different areas of portfolio management to get a better understanding of each part. In our next webinar, we will be discussing the balance between innovation and the mastering of consolidation with technology portfolio management. I'd be happy to see you there again. Until next time, take care.